Hello everyone and welcome to the lecture on AWS Step Functions. So this lecture will contain all these topics. What is AWS Step Functions? Standard and express workflow types, feature comparison, and then use cases, function orchestration, branching, error handling, human in the loop, parallel processing, dynamic parallelism, service integration patterns, and optimized integrations. So what is AWS Step Functions? AWS Step Functions allows you to create workflows, also called as state machines, to build distributed applications, automate processes, orchestrate microservices, and create data and machine learning pipelines. Step Functions is based on state machines and tasks. In Step Functions, workflows, which are state machines, are a series of event-driven steps. Each step in a workflow is called a state. A task state represent a unit of work performed by another AWS service, such as calling an API. Instances of running workflows performing tasks are called executions in Step Functions. The Step Function console provides a user-friendly interface where you can visualize, edit, and debug your application's workflow. This feature allows you to examine the state of each step in your workflow, ensuring that your application runs in the expected order and produces the desired outcomes. Step Functions can seamlessly integrate with other AWS services. For example, you can have Step Functions call AWS Lambda to perform specific tasks or control AWS Glue to create, extract, transform, and load ETL workflows. With Step Functions, you can automate complex processes and orchestrate microservices efficiently. The Step Function is particularly useful for creating data and machine learning pipelines. You can design workflows that handle data processing, model training, and inference tasks, making it easier to manage complex data science and machine learning projects. Step Functions also supports the creation of long-running automated workflows for applications that require human interaction. This feature is valuable for processes that need manual approval steps or human input at certain stages of the workflow. So standard and express workflow types. Step Function has two workflow types. One, standard workflows are ideal for long-running auditable workflows, as they show execution history and visual debugging. Standard workflows have exactly once workflow execution and can run for up to 1 year. This means that each step in a standard workflow will execute exactly once. Express workflows are ideal for high event rate workloads, such as streaming data processing and IoT data ingestion. Express workflows have at least once workflow execution and can run for up to 5 minutes. This means that one or more steps in an express workflow can potentially run more than once, while each step in the workflow executes at least once. So this is the feature comparison between standard workflows and express workflows. So execution rate, it's 2000 per second. This one can go up to 100,000 per second. State transition rate is 4000 per second. It's nearly unlimited. Pricing model, it's priced by state transition. Express is priced by number and duration of executions. Execution history, this shows execution history and visual debugging for standard. So execution history and visual debugging based on the log level. History access, you can see execution history in Step Functions. For Express, you have to send execution history to CloudWatch. Service integration supports integration with all the services, and both supports integration with all AWS services. Integration patterns support request response, run a job, and wait for callback patterns. So these three are supported for standard, or there are three only. But for Express, it only supports request response, synchronous, and run a job and wait for callback is not supported by Express. Optimized integration support integrations with all services, and optimized integration support optimized integration with some services, not all. So there are two types of service integration. You can basically integrate with all services, but there are some optimized integration where you just through the user interface you can just plug and play and provide data, and it will be good to go. So use case 1, function orchestration. Step Functions allows you to create a workflow that runs a group of Lambda functions, which are steps, in a specific order. In the workflow, one Lambda function's output is passed as input to the next Lambda function. creating a chain of interactions between functions. The workflow completes when the last step is executed, producing a final result. Step functions provide visibility into how each step in your workflow interacts with others, enabling you to verify that each step performs its intended function. Next one is branching. So in this case, let's say a customer has initiated a request for credit limit increase. Step functions create a choice state. So this one in the middle is the choice state. It's part of step functions service. So step functions uses a choice state to make decisions based on the input, comparing the requested increase to the customer's pre-approved credit limit. The request is then routed based on the decision. If it is above the pre-approved limit, it is sent to a manager for sign-off. So there will be different Lambda function or process. If it is below the pre-approved limit, step functions approves the request automatically. So you can have automatic approval, also can have a Lambda function which may take additional step like emailing or some kind of notification. Next kind of use case is error handling. So first one is retry. In this case, for example, a customer has requested a username. The first time your customer's request is unsuccessful. Then using a retry statement, you can have step functions try your customer's request again. The second time your customer's request is successful. So basically he has to request for a different username if it is already taken. Let's see the catch case. So in a similar use case, a customer has requested an unavailable username. Using a catch statement, you have step functions to suggest an available username. If your username takes the available username, you can have step functions go to the next step in your workflow, which is to send a confirmation email. If your customer does not take the available username, you have step functions go to a different step in your workflow, which is to start the sign up process over again. Next use case is human in the loop. So in this case scenario, a customer uses a banking app to initiate a money transfer to a friend and waits for a confirmation email. Step functions interacts with the Lambda using a callback mechanism and a task token. Lambda is instructed to send the customer's money and report back upon completion. Once the friend receives the money, Lambda reports back to step functions, indicating the successful transfer completion. Step functions then proceed to the next step in the workflow, which is to send a confirmation email to the customer, completing the transaction process. So in this case, your friend has to come up, has to take a manual action that it has received the money. So this is the example of human in the loop. So next use case is parallel processing. So let's see a scenario. A customer uploads a video file for conversion into multiple display resolution. The goal is to create 5 different display resolutions to support viewing on multiple devices. Step functions uses a parallel state to input the video file, enabling simultaneous processing of all resolutions. Lambda processes the video file, converting it into 5 different display resolutions concurrently. Next use case is dynamic parallelism. So in this case, this scenario is a customer places an order for 3 items, initiating the order processing workflow. Step functions uses a map state to process each item in parallel, leveraging Lambda functions for efficient handling. For each item, the workflow checks availability, gathers the item and packages it for the delivery. So in this case, there are 3 items. Now all 3 items will be made into a parallel chain, and for example this one is for checking the availability, gathering the item and packaging it. So once all is done, it will be merged into a final Lambda function. So once all items are processed and packaged, step functions proceed to the final step of sending a confirmation email to the customer, which includes tracking information for their order. Okay, next one is the service integration patterns. So let's see what our patterns are supported. So this one is for standard workflow first. So step functions integrates with multiple AWS services, which allows for combined functionality across different services. The default integration pattern is request or response, where step functions calls a service and progresses to the next state after receiving an HTTP response. So this is synchronous. So it waits. So you request, you wait for a response and it comes back, which is the default pattern. Next is run a job, which is dot sync pattern, synchronous pattern, involves step functions calling a service and waiting for the job to complete before proceeding. And third, in the wait for callback with the task token, which is known as wait for task token pattern, step functions calls a service with a task token and waits for the token to return with a callback before continuing. And this one is only for express workflows, which is less than 5 minutes, as I talked about. So express workflows only support the default integration patterns, which is request or response, where step functions calls a service and progresses to the next state after receiving an HTTP response. Next, we'll see some optimized patterns. So these are the optimized patterns, in the sense integrating that with step functions is much easier, because you will find all these patterns in the step functions console. So these are Amazon API Gateway, Athena, AWS Batch, Bedrock, AWS Code Build, Amazon DynamoDB, Amazon ECS, Amazon Fargate, Amazon EKS, Amazon EMR, Amazon EMR on EKS, Amazon EMR Serverless, Amazon EventBridge, AWS Glue, AWS Glue Data Brew, AWS Lambda, Amazon SageMaker, Amazon SNS, Amazon SQS, and AWS Step Functions. And that's all. Thanks for watching.